Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the rotational motion in one shot. This is the best NEET crash course series. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the NEET exam confidently with a good rank. Now let's start about the class. So here, rotational motion main topics is moment of inertia, second topics moment of force, three angular momentum, fourth topics important formula of rotational motion, rolling motion, inertia, which is denoted by I. Basic definition is, if a mass rotates around an axis at a distance r, then basic definition is mass into r square, that is product of the mass into square of distance from the axis of rotation. This is the axis of rotation mr square. So for a single point mass, moment of inertia is defined as I equal to mr square. Now, so for a different mass, suppose here m1 mass, here m2, m3, m4, and these four mass are rotates around this axis, and distance from this axis of different mass is respectively r1, r2, r3, r4, etc. So what is the moment of inertia of this system? Moment of inertia of the system is I equal to m1 r1 square plus m2 r2 square. That is, this is connected by a massless string, and this forms a system. Now what is the moment of inertia of the system about this axis? This will be mass into distance square plus m2 r2 square plus m3 r3 square, okay, m3 r3 square plus m4 r4 square. So this is the moment of inertia of the whole system. That is simply summation of the m into r square, I equal to 1 to n I. So this is the formula of moment of inertia of the system for a single body, single point mass m into r square. If there are different point mass, then we have to write this way. Moment of inertia for a continuous mass system. Suppose this is a rod, here mass of every particle. Suppose this rod is rotated about a vertical line, this is axis of rotation. If the mass of the rod is m and length is l, what is the moment of inertia of the rod about this axis? This is axis of rotation. Now how we calculate the moment of inertia? This is a continuous mass system, distributed continuous mass system. No point mass is present, that is total mass is distributed throughout the uniformly, total mass is distributed throughout the rod uniformly, that is here no point mass is present. Now to calculate the moment of inertia, we dm into r square, integration means summation, so we have to write, suppose a point element, suppose this is a elementary mass dm which is at a distance x, element is dx. Now what is the mass? Mass equal to mass per unit length into dx. So di equal to moment of inertia of this point mass. Moment of inertia of this elementary system is di equal to dm into x square, which is equal to dm. What is dm? m by l into dx into x square. This is di means that is moment of inertia of this elementary stripe. This stripe rotates about the axis at a distance x, so radius is here x and mass into distance square. So this, now total moment of inertia is integration of di. Now here x varies from 0 to L by 2. If we integrate this from 0 to L by 2, 0 to L by 2 m by L x square dx. Also we can integrate from minus L by 2 plus L by 2 anyway. So this is if we integrate 0 to L by 2, then we have to multiply 2, because this portion is double of this portion, the whole, because whole of cylinder is double of this portion. So 2 into this. Now if we calculate this, x cube by 3, that is L by 2 by 3, that is 1 by 12, 8, 1 by 12 m into L square. So this way we can find moment of inertia of the any distributed mass, moment of inertia of the disk. Suppose that is, we consider infinitely point mass forms the whole mass m. Now this is axis of rotation x passing through the center. What is the moment of inertia of the disk? To calculate this moment of inertia, we consider a elementary stripe whose length is elementary stripe at a distance x, and thickness is dx, and the thickness is dx. This thickness is dx. Now first we calculate the mass of the elementary stripe. First we consider it uniformly throughout the area. So here mass per unit area is m by pi r square. This is the mass per unit area into area of this section dm. Now what is the area of this part? Area of this elementary stripe, area equal to length into breadth. If we cut this ring shape, if we cut the ring and extend it, then the shape will be like this way. So here length will be 2 pi x and thickness is dx. So area will be 2 pi x into dx. Area will be, area of this section equal to this. So mass of this part equal to this into this, which is into dA. What is dA? 2 pi x into dx. Pi cancel. So m x dx. This is mass of the this type. Now total now moment of inertia of this part equal to dm into x square, which is equal to inertia of the disk. Radius is r1 and this is r2. So what is the mass is m? What is the moment of inertia of the system? If the whole disk rotates about the vertical axis, then what is the moment of inertia of the annular disk? This is annular disk. X to the power 4 by 4. So r to the power 4 r1 square plus r2 square. So for annular disk, this is the answer. This is the answer. For annular disk, moment of inertia of the annular disk will be this. Moment of inertia of the annular disk will be this, not half m r2 square minus r1. Student makes wrong that it for annular disk result is half m r2 square minus r1 square. Is not. This will be half m r1 square plus r2 square. Here axis is this. So moment, what is the answer? Moment of inertia will be m r square. The hollow cylinder. Hollow cylinder is summation of the ring. This is hollow cylinder. So the axis is this. So here moment of inertia is m r square, because hollow cylinder is the summation of the ring. So moment of inertia of the ring is m r square. So hollow cylinder moment of inertia is m r square. Solid cylinder. Now solid cylinder is the summation of the disk. That is, if we place the different disk one upon another, then solid cylinder is formed. So moment of inertia will be half m r square. Here m is the mass of the cylinder, r radius for solid cylinder. Now hollow sphere. So hollow sphere will be, this is a hollow sphere. Suppose axis of rotation this. So this formula will be 2/3 m r square. Now solid sphere. For solid sphere, the result will be 2 by 5 m r square. Now disk. Now rectangular lamina. Rectangular lamina. For rectangular lamina, the result will be, suppose this is side A, breadth B. This is a rectangular lamina, means thin plate length A, breadth B. So if the lamina is rotates about x, here this is the axis of rotation. So here result is 1 by 12 m square plus u square. This is the result, where m is the mass of the lamina. Now this is the standard moment of inertia. We use this result to solve the problem. Now here one thing is that here axis of rotation, axis as this result is applicable. This result is applicable for the axis of rotation, for if the axis of rotation is passing through center of mass, and normal to the plane, that is, this is the plane passing through center of mass, middle point center of mass, and normal to the plane. So all is passing through the center of mass and normal to the plane. So that is vertical this way. So this formula is applicable when the axis of rotation is passing through center of mass. The axis is only passes through center of mass, and normal to the plane of the that is this way. For this, to calculate moment of inertia for any axis of rotation, that is required. Then we require two theorem. One is parallel axis theorem, and another is perpendicular axis theorem. Now what is the parallel axis theorem? Suppose this is a body, mass of the whole body is m. Now this is center of mass, so moment of inertia about this axis is I. Now we require to find the moment of inertia about this axis. Now we require the moment of inertia of the whole body about this axis. So if the axis is at a distance d from the center of mass, that is, if the distance between this and this is d, then what will be the answer? I dust will be I, that is ICOM plus m into d square. This is the result. So to calculate moment of inertia of this body about this axis, we use this formula, that is ICOM plus m into d square. M is the whole mass of the body, and d is the distance between two axes, this and this. Now this is this axis must be parallel to this line. Then we can use this theory. Use this theory. Okay. Now next, so what is the application of parallel axis theorem? If we calculate the moment of inertia of a rod about this axis, the axis passes through one end of the rod. So this is a rod. The axis of rotation is one end of the rod. So to find the moment of inertia about the axis, I equal to ICOM plus m into d square. Now here center of mass is this, so distance d equal to here L by 2. This d equal to here L by 2. জলে বোতল লিখে নে। d equal to L by 2, so this will be 1 by 12 square plus ml square by 4, that is 1/3 ml square. So this is the result we use. So to moment of inertia of the rod about the one end is equal to 1/3 ml square. This is the result, 1/3 ml square. Perpendicular axis theorem. Axis y, z, and suppose a mass is present, x, y coordinate. So this is origin, and so here is the mass is present. So from the origin, that is the distance of the mass from the z axis is r, and distance from the y axis is x, and distance from the x axis is y. So this distance is y, this distance is x. What is the relation? R square equal to x square plus y square from Pythagoras theorem. We write, then we get ix equal to, what is ix equal to m into y square, and y equal to m into x square, okay, and iz equal to m into r square. Now m r square, what is r square? X square plus y square, which is equal to mx square plus my square. Mx square equal to what? Iy. My square equal to what? Ix. So iz equal to ix plus iy. This is the perpendicular axis theorem. That is xy, z axis. Z axis, a axis which is perpendicular to both the axes x and y. So moment of inertia of the any line and is equal to ix plus iy. Ix, now this line is perpendicular to both the line x and y. So the result will be this: iz equal to ix plus iy. You are asked mass m, radius r. You are asked find the moment of inertia of the disk about the diameter. Find moment of inertia of MOI about moment of inertia of disk about the diameter. So here we have to use perpendicular theorem because this is ID. Now any line, so this is suppose this is x-axis and one diameter, we can use this is as this is, we can use the other diameter as y-axis. So z-axis is normal to the plane. Now what is the moment of inertia of the disk about z-axis? Z-axis is normal to the plane. So iz equal to, we know the formula is half m r square. Now iz equal to, we write here id ix plus iy. Now ix equal to id, actually ix means id about diameter. Id plus id, both are diameter, so moment of inertia will be same. Id plus id equal to this. So id equal to 1/4 m of r square. So we know the moment of inertia about the z-axis, that is axis which is normal to the plane. Now we have to find moment of inertia about the diameter. Diameter is in the plane of the disk. Diameter is in the plane of the disk. So here here we have to use the perpendicular axis theorem, which is iz equal to ix plus iy. Ix and iy both are diameter. So moment of inertia will be same for x-axis and y-axis. id plus id equal to this, so id equal to this. That is when we have to calculate moment of inertia of any axis which is in the plane, when both parallel axis and perpendicular axis theorem both required. When suppose find the moment of inertia of the disk, find moment of inertia of disk about the tangent, which is in the plane of disk, find moment of inertia of the tangent. This tangent is the plane of the disk. Now one tangent we can use this way, that is, this is if the disk is in my hand, and another the tangent is one tangent can be drawn in this way, but this tangent is in the plane of the disk. This tangent is in the plane of the disk. So you have to mention the tangent which is in the plane of the disk. So what is the moment of inertia about this axis? Now find moment of inertia of the disk about the tangent which is in the plane of disk. So, this is the tangent which is in the plane of the disk. What is the moment of inertia? To find moment of inertia about this point, we have to first find out the moment of inertia about the diameter, then use the parallel axis theorem. So about the diameter, what is the formula? Formula is 1 by 4 mr square. I have derived previous about diameter moment of inertia this. Now the distance is r, distance between two axes is r, so I equal to id plus m into r square by parallel axis theorem, parallel axis theorem. So id equal to this, that is, this is the answer. Now if we are asked that find the MOI about the tangent, tangent which is perpendicular to the, which is normal to the plane of the disk. This is tangent which is normal to the plane of, normal to the plane of disk. So now here we have to use I equal to the center ICOM plus m into r square, which is half mr square plus mr square, that is 3 by 2 mr square. Okay, this is the answer. So if the tangent is like this way, that is lies in the plane of the disk, then answer is this. And if the tangent is normal to the plane, that is two axes here, this and this is ICOM equal to half mr square, and this is the tangent of the system. Suppose T disk is placed in this way, find the moment of inertia of the system about the line this. So this line is in the plane, the line is in the plane of disk is the plane of disk. So find moment of inertia of the system. This is the disk, 3 disk, mass m, radius r. Find the moment of inertia. So to find the moment of inertia, here this line is tangent to the two disks, and this line also passes through the, this line is the diameter of the disk and tangent of the two disks. So I equal to 2 of I tangent, this is tangent, and this is diameter. This line is diameter of the disk and tangent of the disk, two disks. So we use 2 into it plus id. It equal to what? It is moment of inertia about the tangent this. So this is the diameter. So diameter formula is mr square plus mr square into 2 plus id equal to 1 by 4 mr square. So this is the 3 disk moment of inertia about the line. We have to find the moment of inertia about this line. Now this line is the diameter of the disk and tangent of the two disks. So moment of inertia will be 2 it plus id. It is moment of inertia about the tangent. So formula is this tangent is parallel to the diameter. So using parallel axis theorem, we get this. This is the moment of inertia about the diameter, id of the disk. We know this formula plus mr square due to parallel axis theorem, because these and these distances are into 2 plus id equal to 1 by 4. So this is the result. 4 point mass is placed at the vertex of a square, side is a, find moment of inertia about the axis. Suppose this is a line, which is parallel to the diameter this, which is parallel to the diameter this. What is the moment of inertia about this line? Moment of inertia about this line. Suppose this is y dash. Find moment of inertia of system about line this. So what is the solution? This is square side A. So what is the solution here? The solution here is moment of inertia about this line, and this line is plane of the square plate, plane of this system, in the plane of this system. So here point mass is given, point mass. So to find the moment of inertia, we have to find the distance, this distance, this distance. We have to find the distance from the axis of this axis, distance of this point from this axis. So this and this distance same. So we have to find this distance, this and this same. Now what is the distance? Distance is root over 2a, and this distance is d2 equal to half of this, that is a by root 2. So moment of inertia about this axis I dash equal to this mass is passing through the axis, so it is not considered. Then for 2 mass, this will be 2 into m d2 square, because distance is d2, and for this mass m into d1 square. So 2 into m into d2 equal to this, plus m into d1 equal to this. So this is the answer. Okay, find moment of inertia about the line y dash. Now the line is plane of the system, so this will be the line is this mass, the axis passes through this mass, so this mass is not considered. Now we have to find m into r square. R means distance of the point mass from the axis of rotation. This is the axis of rotation, so we have to find the perpendicular distance of the point mass from the axis of rotation. So this distance is, this is the diagonal of the square, root over 2a. Now half of the diagonal is this, so 2 into m into dt square plus this, d2 equal to this, and d1 equal to this. So this is the answer. Calculate this is the answer. Moment of force or torque. What is moment of force or torque? Suppose a body is hinged at this point. This is a point A. This body is hinged at the point A, and a force is applied at this point. A force F is applied through the point B. Now if the body is hinged at that point A and a force is applied, so thus this body is rotate in this direction, anti-clockwise way. So what is the moment of inertia or torque about this point A? So moment of inertia or torque of the force F about the point A, moment of force MOF, moment of force or torque about point A is defined as R cross F. What is R? R is this line, this is R, and F is this. So this is the definition of R is this is the angle theta. So R cross F is the moment of force or torque about point A. Now this is defined as torque R cross F. So magnitude of the torque is R F sin theta. What is theta? Theta is angle between R and F. This is R vector, this is F vector. Angle between R and F is theta. So F into R sin theta. Now what is R sin theta? R sin theta is actually, if we extend this and draw a perpendicular, this distance is D. So r sin theta equal to F into d. So magnitude of the torque or moment of force is product of force and magnitude of force and perpendicular distance of the force from the point of rotation. So about this point the body rotates. So from this point draw the perpendicular and this distance is d. So torque is product of the magnitude of force into perpendicular distance. Actual definition in vector form is r cross f. What is r? R is this AB vector is hinged at point A. Oh. Now a force this is the question. A body is hinged. What is the question? A body is hinged at point A. Now a force F is applied on a body through point B. Find the moment of force about point A. So this is a suppose body is hinged at the point A and B is a point here. The force 3I plus 4J plus 5K. Point B is 1 2 3. So a point body is hinged at the point A and the force F is passed through the point B. So what is the moment of inertia about the point AB? What is the moment of inertia about the point A? So this is r vector and this is F vector. So moment of inertia, moment of force equal to r cross F. What is r? R is, I have defined r. I have discussed that r equal to AB vector cross F. AB equal to what? What is AB? AB is the position coordinate of A and B is given. Now take the origin is here. So what is AB? AB equal to actually OB minus OA. OB minus OA cross A vector. So OB what? OB equal to OB equal to I plus 2J plus 3K minus OA equal to 2I plus 3J plus 4K. This is OB minus OA cross F vector. What is F vector? F is this vector. So this equal to minus I minus J minus K cross now what is the result of this? If we apply I, J, K minus 1 minus 1 minus 1 3 4 5, so this will be I into this minus 5 minus plus 4 minus J into this minus 5 minus this minus J into minus 5 minus of plus 3 plus K into this minus 4 plus 3. So this is the result minus I so this is the moment of force. Magnitude of this is equal to root over magnitude moment of force magnitude equal to root over 1 plus 4 plus 1. This is the answer. Okay. So this is the vector calculation, cross product of vector. We know the cross product of vector, moment of linear momentum, angular momentum equal to moment of linear momentum, that is r cross mv. This is the definition of angular momentum. This is the formula of angular momentum, r cross mv, that is moment of a force is defined as r cross f. This is torque, and angular momentum is defined as moment of the momentum, r cross p. So this is angular momentum, this is torque. P means mv. Moment of linear momentum is angular momentum. So magnitude equal to r mv into sine theta. What is theta? Theta is angle between r and mv. Here two vector, r and velocity vector or momentum vector. So angle between r vector and momentum vector is theta. So magnitude r mv sine theta. Now this is equal to mv r sine theta. Now what is r sine theta? Suppose a body of mass m is moves with a velocity v parallel to the x-axis. Suppose this is x-axis and this is y-axis. Suppose a body of mass m is moving with velocity v parallel to the x-axis. Now this is the origin. Now what is the angular momentum of the body with respect to O? So the body moves linearly, but about the point O, the body makes angle at different position. So these are the angle made at different time. So angular momentum is defined at the angular momentum of the body with respect to O. About the point O, we define the angular momentum of the body, but the body is moving linearly, that is moves in a straight line. But about the point O, we define it is angular momentum. Angular momentum about the point O is defined as, suppose any moment the position is this. So this vector is r, and the direction of r vector is this way, and the momentum vector is this way, and the momentum vector is this way. So if we find the angle between two vector r and mv, so here we have to produce this such that two tail at one point. So this is the angle between two vector. So this angle and this angle same. So now the moment of, so this is r, this is theta. So what is angular momentum equal to r mv sine theta, mv into r sine theta. Now what is r sine theta? R sine theta is perpendicular distance, this that is mv into d. So if a body moves linearly, moves in a straight line parallel to the x-axis, so angular momentum about the point O remains constant, because here m, v, d, every terms is constant. Suppose the body is at here, the distance is d, remains same. The body is at here, distance same. So if the body moves with uniform velocity, that is constant velocity, the moment of if the body moves with uniform velocity, the angular momentum about the origin remain constant throughout the motion, Formula conservation: if torque equal to 0, if external torque equal to 0, then L remain constant or conserved, or initial angular momentum equal to final angular momentum. Initial angular momentum equal to final angular momentum. This is the conservation of angular momentum. Now we define L equal to I omega. This is the formula, L equal to I omega, where I is moment of inertia. Moment of inertia is a scalar, but omega is a vector, and omega vector and angular momentum vector equal to same. So L equal to I omega, we defined mass m, radius of the circle is r, the body moves with angular velocity omega, and linear velocity v. So angular momentum equal to r mv sine 90 degree, because r and velocity vector angle between r and velocity vector is 90 degree. So angular momentum is r into mv into sine 90 degree, which is equal to mr. Now v, what is v? V equal to r omega, we know. So r omega put here. Now this is mr square into omega. Now mr square equal to I. So L equal to I omega. We defined L equal to I omega. Now for conservation of angular momentum, if no external torque is applied, that is this equal to 0, then I omega equal to constant. I omega equal to constant, that is I1 omega 1 equal to I2 omega 2. So this is important formula conservation of angular momentum. So now what is the question comes is another disk moment of inertia is I2, rotating with angular velocity omega 2. Now this disk is placed gently upon the disk. This disk is gently placed on the disk. Now the combined disk, what is the angular velocity of the combined disk? What is the angular velocity of combined disk? So we solve this problem by conservation of angular momentum, as there is no external torque is applied. So initially before placing, total angular momentum of the system is I1 omega 1 plus I2 omega 2. This is initial, and final moment of inertia is added. Moment of inertia is scalar quantity, so this is added. Now two disks moves with a common angular velocity, not different. The two disks adjust itself due to friction and rotates with a common angular velocity. So this equal to divided by I1 plus I2. So this is the answer. Now if the disk rotates about this position, suppose this rotates in this direction anti-clockwise, and this disk rotates with clockwise direction, and if the disk is placed upon this, then what is the angular? Then this will be negative. I1 omega 1 will be negative, minus this. If we take this is positive sign and this is negative sign, so now initially the angular momentum will be this minus this, and here this will be plus, so answer will be minus of plus. Answer will be minus plus of this. Moment of inertia is always added, it is not subtracted. This is vector quantity, so initially angular momentum will be this minus this, and final angular momentum is this. So now the result is this. Now here one important thing is loss of kinetic energy. Loss of kinetic energy due to combination. Suppose this disk is rotate first, take positive sign. So two disks rotates in the same direction, then loss of kinetic energy will be half I1 I2 by I1 plus I2 into omega 1 minus omega 2 whole square. This is the formula. Loss of kinetic energy if the two disks rotates in same direction. When both disks rotates with same direction, then loss of kinetic energy is this, and when it is rotate in different direction, answer will be loss of kinetic energy will be half I1 I2 by I1 plus I2 into here omega 1 plus omega 2. By calculation we get this result. Torque equal to I into alpha. First equation is this. Second equation is dl by dt. Rate of change of angular momentum equal to torque. Third equation is angular momentum equal to I omega, I have discussed already. Fourth equation is kinetic energy of angular kinetic energy equal to half I omega square. So in angular motion, m is replaced by I. This is for linear motion and this is for angular motion. So in linear motion, force equal to ma. This is for linear. So in angular, force is replaced by torque, m is replaced by I, and a is replaced by alpha. And this is dl by dt means rate of change of angular momentum, and angular momentum L equal to I omega, kinetic energy equal to half I omega square. So in linear motion, what is linear momentum? Half m into v square. This is for linear and this is for angular. Same is rotating with angular acceleration alpha and linear acceleration a. So the radius is r. Now what is the torque? Torque equal to force into perpendicular distance. What is the force? Force here is Ft, tangential force. So tangential force into perpendicular distance r is 90 degree. So Ft equal to what? Mass into linear acceleration r into, so m into at equal to what? R alpha into r. So m into r square into alpha, m r square equal to I into alpha. That's why torque equal to I alpha we get. So actually torque equal to force into perpendicular distance. Force here Ft force is act. Here also normal force act, but normal force, torque of the normal force, torque of the, this is conceptual problem. This from this conception MCQ may comes. So torque about normal force or centripetal force is 0. Torque about normal or centripetal force is 0. Torque of normal or centripetal force about center is 0. Only torque of tangential force present. So torque of tangential force is force into perpendicular distance. Force equal to ma, a equal to r alpha, m r square into alpha I alpha plus r cross m into dv by dt. So this formula is dr cross dt. Dr by dt means what? Dr by dt means v. So v cross mv plus r cross dv dt a ma r cross f. So r v cross v, m is constant, v cross v, same vector, cross product of same vector equal to 0 plus r cross f. Now what is the r cross f? R cross f equal to torque. So dl by dt. So dl by dt equal to torque. It is proved. dl by dt equal to torque. This is very very important formula. Important. Now what is the question for this? Question related to this equation. Suppose this is a stand, this is a disc. Now m, mass m, radius r. This is pulley, this is rotating pulley. Now if the pulley rotates when it descends, the block is descending and the pulley rotates. What is the acceleration? What is the acceleration of block of mass m? This is the question. In this diagram, this pulley can rotates, and when this pulley can rotates when this block is descending downward. Now what is the acceleration of block of mass m? In Newton's laws of motion, pulley was fixed and the block just moves. This is fixed, but here the pulley rotates. If the pulley rotates, what is the acceleration of the block? M. what is the acceleration of the block of mass m, and here the pulley is this whose mass is m and radius r. So moment of inertia about this equal to half m r square. We can use half m r square. So to find the acceleration of the pulley, we have to draw free body diagram. Suppose mg act in direction tension T and acceleration A. Now for the pulley, this is tension T, and so this pulley tension is T, and here radius is r. Now equation of motion of block of mass m equal to mg minus T equal to ma. So this is equation 1. Here mg minus T equal to ma, and for this pulley, what is the equation for pulley? For pulley, what is the equation? Equation equal to torque equal to I into alpha, torque equal to what? T into r. I moment of inertia half mr square into alpha equal to a by r, because here the string is not slipping, so here linear acceleration a equal to, we use r into alpha. What is the linear acceleration? Linear acceleration at this point equal to r into alpha. We have the result a equal to r alpha. So here alpha is angular acceleration. Now torque equal to force into perpendicular distance. What is the force? Force here is T. Force into perpendicular distance equal to torque. So torque at here we use T into r. I equal to half m square, alpha equal to a by r. So r cancel, equal to ma by 2. Now put here ma by 2, we get 1 mg minus T equal to ma by 2 equal to ma. So a common, m plus m by 2 equal to mg. So a equal to mg by m plus m by 2. This is the answer. Okay, this is the answer. Acceleration of the block is this. A rolling body in an inclined plane. So suppose this is an inclined plane, and a ball is rolls means it moves and also it rotates. This is the rolling motion. Now if the angle of inclination is theta, friction is present. If there is no friction, then it cannot rotate. So friction is present. Due to friction, the body, the ball, any body rotates and also it moves. So it is rolling motion. Now what is the acceleration of the rolling motion? Acceleration equal to what? For this motion, what is the acceleration? Now to find the acceleration, what is the equation here? Mass of the body is m. Here mg sin theta acts in this direction, friction acts in this direction. Now what is the equation of motion? Mg sin theta minus friction equal to ma. This is equation 1. And another equation is torque. As it rotates, another equation is torque equal to I alpha. What is torque? Torque about the body rotates about the center. So torque equal to force into perpendicular distance. Here force is F. We consider this force provides no torque. This force provides no torque as it passes through the center, because distance of this force from the center is 0. So here friction provides the torque. So torque equal to friction force into perpendicular distance is r. So I into alpha equal to a by r. So from this we get friction force equal to I a by r square. Now if we put friction force at here, we get the acceleration. So mg sin theta minus friction force I by r square equal to ma. So a sin theta. So a equal to mg sin theta by m plus I by r square. Now here one important term is moment radius of gyration, radius of gyration or gyration, radius of gyration or gyration, anybody may spell it different ways. Radius of gyration equal to what? If radius of gyration is k, then we know I equal to, definition is I equal to f k square. This is the radius of gyration. I equal to, I is moment of inertia. So if we put I equal to mk square here, what is the result? A equal to m plus I mk square k square by r square. So plus a square by r square. This is the result. Acceleration. This is the result. A equal to this. Suppose this is a height h. A ball, a sphere or ball is released from this plane whose inclination is theta. Now it rolls. It rolls. Now what is the velocity when it reaches at the bottom? What is the velocity? What is the velocity? Suppose this is a sphere of mass m, radius r. When it comes at the bottom, what is the velocity? What is the velocity? Here we have to apply mechanical energy. Total energy remain constant. Total energy remain constant. So here total potential energy is converted to kinetic energy. Total potential energy here potential energy is converted to kinetic energy. Here potential energy is 0. So potential energy at this position is mgh and kinetic energy at this position is half I omega square plus half mv square. Now I equal to, if this is sphere, then I equal to 2 by 5 m r square omega square plus half mv square. Now if r square omega square equal to v square, so 1 by 5 plus half mv square, which is equal to v square. So v equal to cancel, so v square equal to 10 by 7 gh, v equal to root over 10 by 7 into gh. So this is the answer. It rotates also with angular velocity omega. So BPF body simultaneously moves and rotates. This is rolling. Rolling motion means pure rotation plus pure translation. Both motion combined forms the rolling motion. Pure rotation plus pure rotation. So this equal to actually, so this is omega, this moves with velocity v, center of mass moves with velocity v, and this omega. So this plus this forms this. This is pure translation and this is pure rotation and this is rolling. So rolling equal to translation plus rotation. Before in the translation motion, every particles of the body moves with same velocity v. Every particles on the body moves with same velocity, which is the velocity of center of mass. v same. The v is the velocity of the center of mass. So everybody moves with same velocity, and due to rotation velocity of the center of mass is 0. So due to rotation this body rotates in this way. So due to rotation a extra tangential velocity, linear velocity produced. Due to rotation this moves with velocity, this is r omega. This particle moves with this velocity 0. Now at the point which is distance r by 2, velocity is r by 2 omega, and at the point r by 2 this velocity is r by 2 omega. So this way, this is r by 2, this is r by 2. These particles moves with this particle moves with radius r by 2, so velocity is r by 2 omega, because omega is constant. Omega for every point is constant. Omega for every point is constant, but due to different distance, linear velocity will different for every point, for each point. So this point is at a distance r by 2, so linear velocity r by 2 omega. This point is at a distance r by 2, so velocity is r by 2 omega in this direction, r omega. Now, so if this and this combined, then what comes? If this and this combined, then if this and this combined, then velocity of this will be v plus r omega. Velocity of this point will be v plus r omega by 2. Velocity of this will be only v. Velocity of this point will be v minus r omega by 2, and velocity of this will be v minus r omega. Now, what is the condition for pure rolling? Now, condition for pure rolling is velocity at that point, that is this point, velocity at this point is 0. Condition for pure rolling is velocity, suppose this point is d, velocity at d point will be 0. That is when we consider pure rolling, then there is no slipping at the point of contact. No slipping at the point of contact, that is velocity at d point will be 0. No slipping of point of contact. This is condition for pure rolling, that is Vd equal to 0. As Vd equal to 0, we get V equal to r omega. So for no sloping or for pure rolling, what is the, suppose this point is A, this point B, this point C, this is point, suppose M. Now, what is the velocity at A in condition of pure rolling? This will be V plus r omega, that is 2V. Velocity of B equal to V plus, put r omega equal to V, so V plus V by 2, that is 3V by 2, and Vc equal to V, and Vd equal to 0. Vm equal to V minus V by 2, that is V by 2, and Vd equal to 0. So if a body moves with velocity V, then we get different velocity at different point in this way. Suppose a body moves with velocity V, and this is a point here, this is a point R. This angle is suppose 60 degree. Now, if a body rolls whose angular velocity is omega and velocity of the center of mass is V, then what is the velocity at this point P, which is angle 60 degree with horizontal? So what is the velocity at this point? Vp equal to what? How we calculate velocity of this point P? How we calculate velocity of the point P? Now, here for pure translation, velocity of this point is V. We know velocity for pure translation, velocity of each point is same that of velocity of center of mass. So due to translation motion, velocity is V. Now, due to rotation, a velocity developed in this direction. So due to rotation, this a tangential velocity produced. So this velocity is r omega. V equal to V, because we know V equal to r omega. So V equal to r omega. As pure for case of pure rolling, V equal to, we know, r omega. So this equal to V. Now, what is the angle between this angle is, so this is 60 degree, so this will be 60 degree. Now this angle is 30 degree, because this and this is 90 degree, 30 degree. So velocity at point P will be root over V square plus 2V into V cos 30 degree. If this point is for calculation 30 degree, this angle will be 30 degree and this angle will be 60 degree. So 60 degree. Now this will be cos 60 half, so 3V square, that is V into root 3. So in this way we calculate velocity at any point P. Now if the point is at here, suppose the body moves with velocity v and angular velocity omega. Now what is the, this is angle 30 degree, what is the velocity at this point, which is at a distance r by 2, which is at a distance r by 2, r by 2. Now this body rotates with the radius r by 2. Now what velocity of this, due to translation v and due to rotation, velocity is r omega by 2, which is v by 2. Now this is 30 degree, so this is 30 degree, this is 60 degree. Now the answer is velocity at the point P will be root over v square plus v by 2 whole square plus 2v into v by 2 cos 60 degree. So this is the answer. This is velocity of center mass v and omega is angular velocity. Now this is origin, this is mass, this is disk, mass is m, radius is r. So this is origin. This disk rolls and moves along the x-axis. Now what is the angular momentum about the origin? So angular momentum of rolling body. Now angular momentum about the origin will be L of center of mass plus L so total angular momentum equal to LCM, total angular momentum of this system equal to center of mass, angular momentum of center of mass plus angular momentum of about the point O. This is the angular momentum of the body disk, angular momentum about point O. So this is the formula. L about the angular momentum of the disk equal to LCM, angular momentum of the center of mass when it pure rotates, and angular momentum about the origin. Now what is LCM? LCM means if the body rotate pure rotation, for pure, this is applicable for pure rotation and it is translation applicable to pure rotation. So if your body rotates, what is the angular momentum about the center of mass? This will be I omega, we know I omega. And what is LO about the point r cross mv, we know the formula is r cross mv. Now I omega, that is, this is a vector quantity, so we take the magnitude. This vector and this vector direction will be same, the direction will be same. So if we take magnitude, this is omega. Okay, now suppose r cross mv, direction of r cross mv and omega will be same. Now if we take the magnitude, L magnitude, so this is I means, suppose this is a disk, so I is half mr square into omega equal to v by r plus this is mvr sin 90 degree, because mv and r, angle between mv and r is 90 degree, so sin 90 degree, this is r mvr. So what is the result? mvr by 2 plus mvr, that is 3mvr by 2. So this is the answer, 3mvr by 2. So what is the angular momentum of the disk about the origin? So what is the angular momentum of the disk of the rolling? What is the angular momentum of the rolling disk? This will be angular momentum of the center of mass when it is pure rotates, when it pure rotates, and plus angular momentum about the origin. So if the disk moves with velocity v, angular momentum about the origin equal to r cross mv, and pure rotation it is I omega. So put the value of I omega, I equal to half mr square, v equal to omega r, so omega equal to v by r, put here, and here r cross mv, what is the r is this, and r cross mv, if we so r into mv into theta, sin theta. Now r sin theta, what is r sin theta? R sin theta equal to r plus mvr, which is 3/2 mvr, 3/2 mvr, because r sin theta here, this is r, this is sin theta, so r sin theta equal to capital R sin theta equal to capital R, this. Student, this is the end of the class today. To get important problems on NEET exam, watch my another video. Okay, thank you.